Hey guys, welcome to Bar Z. My name's Stan, and today we're going to talk about some pneumatics and controlling an air cylinder speed and different types of flow controls. Now you see I've got 4 flow control valves here, and I've highlighted the schematic on them so actually you can see them a little better. Let me zoom in just a skosh here. Try to get you tight on that. Now I've highlighted these with a Sharpie. And you'll see this one as a schematic, and we're going to decipher these schematics and tell you what they mean. And then here is the other one that I highlighted. Yeah, it's showing up pretty good, but I'll put them kind of side by side here. Hopefully you can see those two. You can see there is a very subtle difference between the two. And we're going to go up on the whiteboard and draw both of these schematics, tell you what they mean and what they mean for the way your air cylinder behaves. Now these can be set up to meter on input or meter on output, so it's a difference between metering in and metering out. So we're going to get a little deeper into it and discuss the pros and cons of metering in against metering out. All right. Okay, first of all, what you see up here on the board is a typical air cylinder. These rules pretty much apply to hydraulics and pneumatics both. So, and the diagrams are the same. The medium you're working with, the air or the hydraulic, they're going to act a little bit differently in your situation, but this one is applied just to pneumatics. But the schematics are the same between hydraulics and pneumatics. We've got a cylinder here. This is an air cylinder. This is a double acting air cylinder. We've got the piston end and the rod end. The way we've got these, this is the same schematic that you saw on this little valve that I showed you a little while ago. And everything that gets represented there is a orifice, which is adjustable. This is indicating an adjustable orifice. This is indicating a check valve with a ball. And the little V indicates the seat. So when fluid passes this way, that ball gets slammed into the seat and fluid can't pass. But if it backflows, it's free flowing. Now, this is what's called metering in. This metering on your input. And when I say in, it doesn't matter whether the cylinder's retracting or extending. It's on the input of the cylinder. When we apply air here, we're pushing air up here. Can it pass here? The ball gets slammed into the seat, so our air stops right here. It's forced to go through this orifice. So we fill this cylinder from here, regulated. As the air cylinder is moving, this side of the air needs to be expelled, and this goes to exhaust through our spool valve or whatever we're using. Now we're pushing this cylinder or this off of its seat, this metering control. So we're pushing air this way. Our seat opens and we free flow back to exhaust, and that exhausts out. Okay, now let's move the air in the opposite direction. Let's make this the exhaust this time. We're going to send air this way. It's going to come up to here, stops there because it can't go into that check. It's going to go in through this regulated orifice here. It's going to fill the rod end with air and push out this way. Now it's going to push that off its seat and go to exhaust. This whole system is called meter in. So no matter where we put our air to, whether we apply air here or here, it's getting metered on the way into the cylinder on either side. Let's redraw it for meter out. And then we're going to talk about how cylinders react to that and what we do to stop any problems we might have, like a jumpy cylinder, which does happen. We only have to make one change right here. Now if you notice, we're facing the seat and the ball in the opposite direction. So this is considered metering out. And what we're doing now is we're controlling the exhaust side of the cylinder instead of the intake side of the cylinder. All right, so let's say we apply air here. We come up to here, our check valve opens because we're pushing it from the seat to the ball. So we've got an air path all the way there. We fill up here. Now our exhaust comes out and it's trying to send air out to the atmosphere, but it just slammed into the seat closes, and we're metered on the way out to exhaust. All right. And the same works in the other direction. If we bring air in here, we're free flowing here, fill the cylinder, the rod end of the cylinder, and we're controlling the exhaust end of it. When we come out this way, a ball gets slammed into the seat and we regulate on the way out. So this is metering out. The problems that you may encounter when setting up a system and which you want to know which way to go, what should I do? There's no cost involved in which valves you buy. These valves are identical in price. But let's say you get a jumpy cylinder. You fill this up with air and it's free flowing on the exhaust end. It's just to atmospheric, it's ready to go. But that cylinder will fill and jump and fill and jump and fill and jump. And as the pressure equalizes that cylinder, you can get a jumpy cylinder. And that's not even including any mechanical things that you introduce into the system. It can do it just with the pneumatics. So if you've ever gotten a jumpy cylinder, that's probably your metering on the way into the cylinder. If you meter on the way out of the cylinder, it gives it a cushion to push against, and there's a constant flow of exhaust air, and it will cause your cylinder to move in a fluid motion. And easy way to remember it is when in doubt, meter out. Your seats face away from the cylinder on meter out, and your seats face towards the cylinder on meter in. And that's what those little diagrams mean on your fittings. Make sure you take a good hard look at those. Make sure you know what you're doing. Either one will work. But if you want a nice fluid motion, meter out. So that's my tip of the day. When in doubt, meter out. Thanks for watching.